Good morning, everyone. Good morning to our students from Chile and good evening to our students from China. Thank you for being here. My name is Osvaldo Guzman. I am from the University of Chile. So today we'll have a session called Climate Change presented by Professor Laura Gallardo from Universidad de Chile as well. This is the last webinar from the China-Chile Online Education Week. We've had some amazing classes from professors from China and Chile since last week. And this activity is framed in the celebration of the 50 years of diplomatic relations between China and Chile. So I'd like to introduce today's presenters. Dr. Laura Gallardo, she's a full professor at the Department of Geophysics from the Faculty of Physics and Mathematical Sciences at the University of Chile. She holds a PhD degree in chemical meteorology from the University of Stockholm in Sweden. Her lines of research are atmospheric modeling and data simulation, air quality in megacities, and short half-life pollutants. Professor Gallardo was the first director of the Center for Climate Change and Resilience Research, and currently she's the lead author of the 6th assessment report of the Intergovernmental Panel on Climate Change. So Professor Gallardo, the floor is all yours. I will share my screen now.
Good morning, good evening, ni hao. That's one of the few words I've learned so far. I always tell my students they are supposed to learn Chinese. Eventually, Chinese may become the lingua franca for science. Not yet. Still, we have to speak English, but who knows? In the future, I prefer to have Spanish, of course, as my lingua franca. Well, let me start this talk by thanking the University of Chile and the universities, all the universities involved, for inviting me. And then I'll go on into trying to assert a few things regarding the center which I belong to or which I'm a part of. And also trying to get closer to you guys. This map, what shows is essentially the antipodes. Santiago roughly is the antipodes of the city where you have your warriors. I don't remember the name of the city. Maybe it's I'll come to that later if I come to that. But essentially, we are closer than you would think. We have a notion that unites us, and we have many issues at hand that are similar for both countries. So the outline of the talk is, first, I will be dealing with what and why CR2 exists. Then I will go and talk about the science in the Anthropocene, this epoch when humans have impacted the climate system to such an extent, which manifests itself in many ways, but also brings the need for doing science a bit differently than we have done before, or at least making it more explicit. And that difference is essentially the third point of the talk, which deals with the crossing bridges, the need of crossing bridges between science and policy, and to some extent also with politics, understanding politics as a way of living together in a planet and sharing this planet among all of us. Then I will go into a few research highlights of the center and finally a short summary. So thanks a lot for the invitation and for this opportunity for sharing with students from Tsinghua University, Peking University, Beijing University, and the Jiaotao University. Okay, first a confession, a glad confession. I don't know whether you are, some of you are students of Professor Tong Su at Peking University. He was one of the distinguished members of our advisory panel, international advisory panel. And here's a picture of Professor Tong Su when we were celebrating the 5th year of the center, in which we also had the visit of President Bachelet, the former president of Chile, in 2017. So I have some sort of connection with China. I've had the chance of visiting your country, I think like 3 times already. And so I kind of feel some sort of connection with your country. So that's a confession I wanted to make. So let's go into the issue at hand. Let me tell you first the story of CR2. The Center for Climate and Resilience Research is a center of excellence funded by the Chilean state through its science council, let's say, or agency. And as any research center, we have as a purpose first to deepen our understanding of the climate system, processes and impacts through Chile to begin with, in a holistic manner that confronts the complexity of socio-ecological system. Essentially, we do not only address the physical parts or the physical chemical parts of the climate system, but also we include humans, which is essential if you are to understand climate change and anthropogenic climate change to begin with. Then this country, nowadays we have roughly 18 million people, which is a low number compared to the number of people living in China. And our community of researchers dealing with climate change is relatively small. So when we started in 2013, that community was even smaller. So one of the objectives of the center is to promote the growth and the strengthening of this emerging community of natural and social scientists working in earth system science in Chile. And the third objective, which is a bit different, perhaps to some other centers of excellence, is that from the very beginning, we started deciding that we wanted to have some sort of a connection with stakeholders, with decision makers, in order to contribute to the definition of climate change, adaptation, and mitigation measures. So we are able as a country to build what we would call societal resilience. This ability to cope and to adapt and to learn from the challenges posed by climate change. Chile, here below you can see a map of precipitation essentially over Chile, or over continental Chile at least, this long country extended from 18 south to 53 south in the continental South America, plus our interest of Antarctica. But you can see is a strong gradient between a very dry northern part of the country with the driest desert in the world, and very heavy precipitation areas to the south. So we have a physical gradient that's very strong, north-south, but also east-west, because we are by the Pacific Ocean, this ocean that unites us. But also we have the Andes, the very high mountains. So we have gradients in all directions. And those gradients are also social and socio-economical. And that's also a factor to be considered when we try to understand the science of climate change and its manifestations along and across this country. So in terms of a philosophical point of view, our center aims to have, there is a quest for fundamental understanding, but there is also a consideration of use. We want our science to be useful. And this is classified typically in terms of quadrants, and our science is more use-inspired, not everything. We also have strictly curiosity-driven science, but a large fraction of our efforts are oriented towards use-inspired research, what is called the Pasteur quadrant. So here we are. So our science, this is a picture I will show you later, but essentially this is the way we are organized nowadays, in which we have different areas of research: cities, coastal zones, water issues, land use issues, and governance. And in addition to that, we have integrative questions that we ask ourselves in order to integrate these different areas of research. And in that areas, in these integrative questions, we try to make this connection with society. So from the very beginning, our center deals with trying to understand this complex world, and we do that by doing research, and we do modeling and some observations, and we publish papers, etc., etc. We try to strengthen the community, and these rabbits try to show that. So we have a diverse community and a growing community. And finally, we try to cross this bridge between decision making and science, something which is not easy. And I will try to go a bit deeper into how we have done it so far. First, it's the science of climate is a science that requires the perspectives, the concurrence of many sciences. One cannot understand the climate system if one looks at it from the perspective of a physicist, of a chemist, of a sociologist, of a politician, of whatever perspective you have. If you look at it only from your perspective, you won't understand the issue. It's like this reference to an old fabula from India, in which if you want to understand this complex system, in this case, this elephant, you have to understand it through the perspective of multiple disciplines. And more than just having multiple disciplines, you have to have a common view, a common understanding, and that requires interdisciplinary research, which is relatively easily written on paper, but it's much more difficult to put it in action. And that's an effort we have made so far. Now, a second reason for that, well, we are in a world that is changing rapidly. Some people talk about planetary boundaries that have been trespassed over the last few decades, essentially, or that began with the Industrial Revolution and that has been accelerated since the mid of the last century, from the 20th century. And here is a picture trying to describe to what extent these boundaries are surpassed. The integrity of the biosphere and also fresh water is absolutely surpassed. We have reached in many points, in many areas regarding biosphere integrity, points of no return. We have lost a part of the biosphere integrity, particularly over land. We have lost species, and we continue to lose species at a very fast rate. Also, the biogeochemical cycles of sulfur, nitrogen, carbon, phosphorus, etc., are all very much altered by our activities. Also, having passed these boundaries within which we as humans can survive and can thrive in this world. There is the aerosol loading. Both your country and my country have an issue with that. The number of particles in the atmosphere are altering our health, the health of ecosystem, but also the system, the climate system itself. Climate change, of course, we are in a point where we have also gone beyond the space in which human life has thrived over the last 12,000 years roughly, and we have to take measures in order to come back to some sort of equilibrium. We are out of the equilibrium, and this being out of the equilibrium or outside that range is the times that we talk about the Anthropocene. And the Anthropocene says that we have come to a point where our strength, our way of living have disturbed the climate system, this blue planet in which we all live, to a point that we must take measures to come back to something that is more appropriate for ourselves, but also for the rest of the system of which we are a part of. So essentially, we require intelligent and relevant science in order to find the way to get back to this equilibrium. So essentially, the Anthropocene questions our way of life, and we must learn how to recover our zoon politikon. This is a Greek word in which we are animals, we're zoon. However, we are also political in the sense that we have to live together and to learn to live together and to come to some sort of agreement on how to live together and how to respect each other. So we would like to have our intelligence aiming at developing new coexistent manners in this very blue planet. And that's something that is key for ourselves and for what surrounds us. The problem of the Anthropocene, one of the issues of the Anthropocene, is that even though we have to learn from the past in order to contextualize the present and the future, we don't find many analogs. So many of the solutions must be brand new, things that humanity hasn't thought of before. And many of the changes that are very fast are disruptive of our societies, are surprising in many ways, and overwhelming. And of course, one of the things that had happened, of course, is the COVID-19 experience that has put the whole world in hold because of the way of living we have. Also, solutions cannot longer be slow and incremental. We cannot wait hundreds of years, thousands of years for things to develop differently. We have to change over the next decade. We have to change in your lifetime. Many of you might be in your 20s. Before your 40s, you have to have a world that is completely different. And that requires the effort and the contributions of all, and also audacity and profound changes. And in the same manner, the way we have done science so far has to change. So, and one of the ways in which science and climate science in particular, climate and resilience science in particular, have to change is in first trying to have this common view in order to understand the elephant we have in front of us, but also to be able to make a bridge between science and society at large, but also decision making. So, and that's, of course, it's not trivial, but scientists typically like these challenges of very difficult stuff. So when you want to build this bridge and cross this bridge, which typically is a bit weak, it's difficult. And sometimes you die in your effort. And there are many reasons for that. Decision making and science have very different rhythms. And the timing of everything differs from one aspect, from science and from policy making. You need champions that are to some extent bold enough to go and try to cross this weak bridges. And when you have very small research bodies as those that we have in Chile or we have had so far, then you have to be more careful because the probability of dying in the attempt is a bit greater. So, and in order to do that, and the other thing that typically happens if you make too much of a crossing here, then people from both sides don't recognize you and distrust you. So you have to be very careful in maintaining your identity as a scientist, if you're a scientist, or as a policymaker or a politician, if you are such. So this is kind of a walk through terra incognita that is unknown territory, and that's an adventure that it's not easy, but it's very rewarding, as I will try to highlight. So far, these are different pictures of meetings we have had since 2013 and up to now. Of course, this latest year, the 2020, we have changed this much more interesting way of getting together in nice places along Chile to have these Zoom meetings, but such as life, we have to learn to do that. What we have done is first to identify complex, scientifically challenging and relevant problems that facilitate integration. In order to have a community, you have to have a common language, you have to have an interest. For scientists, that's absolutely necessary. If you don't engage the interest, the curiosity of scientists, then you're lost. For scientists to work, you need to have that light in your eyes that says, this is interesting, this is amazing, this is complex, this is a challenge, this is, and also, this is relevant. I can transcend my science by being useful to society and the world at large. So we have, along the years, identified a number of issues within the broad context of climate and resilience research, trying to identify key issues for Chile in order to be able to do this interdisciplinary and even some transdisciplinary science, trying to cross a bridge towards policymaking. This is a fancy word for saying that cultural and the ways of doing science from the different communities of physicists, chemists, sociologists, etc., mathematicians, these different ways of doing science, this epistemological diversity is necessary. I mean, you have to have people from different backgrounds, but it's not sufficient. If you have people from different backgrounds without a complex issue at hand that make them willing to cross the bridges among disciplines, then you won't make it. You need to have something interesting. So diversity is important, but it's not enough. So you have to put a lot of will, a lot of work and reflection along the way, and professionalize these dialogues among the different disciplines. In our experience, it's been very important to have integrative female leaderships that have helped in balancing the excellence, to balance excellence and relevance. Fortunately, in the case of China, I think the integration of male and female intelligence into science is is quite robust, different from other countries, and one of those countries is my own. But in this case, it's been like that, and it happened because of serendipity to some extent, but also it's something that has helped. And we keep learning. This is a trip, a traveling adventure that we started in 2013, and we are still learning, and we are still motivated to do that. So what have we done so far? First, one of the things we have done is to identify these issues, as I told you. So we produced a number of reports that are written in a more or less accessible manner. It's not written in scientific, so to speak. It's not the same language you use when you write a paper that when you talk with your grandmother or your grandfather about the science you make. Probably many of you have faced the question, what are you doing? What are you learning? Also, the other thing has been to use the internet in order to put platforms of different things for learning and making the science and the knowledge available for the community, but also for policymakers. So we have made so far a number of what we call reports to the nations of Chile, in which we have addressed the drought that we have experienced, and I will tell you more about it, the way this epoch is manifesting itself in Chile, and how to face it, what are the changes that are needed to face it. Fires, of course, is an issue of interest for Chile. We have had terrible consequences of changes in fire regimes in Chile, and I will also talk a bit about it. The air we breathe, that's the latest report talking about air pollution in central and southern Chile, and I'll show you a few results. Black carbon mitigation, this is a part in which we contributed for the Chilean contribution to the Paris Agreement, trying to determine the inventory and the measures and what was possible in terms of the compromise of Chile in order to face climate change from the point of view of air quality and black carbon. In the making are these three reports, one dealing with the governance of the elements that is expected for next year, and two others that have to do with, again, water scarcity in the case of Chile, which is an issue of highest interest for Chile, and hazardous algae blooms. We have also experienced that we are increasingly experienced that. And as I said, many platforms, some of them are dealing with data, standard data, climatological data, air quality data, etc., but also with climate legislation, with some outputs of adaptation measures. So now let me highlight some science, traditional science, so to speak. And the first issue we dealt with was what we called the mega drought. Drought is quite a familiar phenomenon for central Chile, where Santiago is located. That is in the subtropics, sector 3.5 degrees south. And that's because we are an interface between the wetter southern part of the country and the very dry part of the country to the north. And so precipitation patterns change from year to year, and typically we have had droughts from every few years. Some of them quite intensive, say, lasting for perhaps up to a couple of years. But things have changed, and the current situation, because we are still suffering a drought, is that this is a drought that affected us essentially over not only central Chile between 30 and say 35 or so degrees south, but also down to the southern part of Chile, down to 40 degrees south, where the climate was typically very rainy. And this is precipitation data, and the trends shown over here, and you see, or you can see, very brownish color. That means essentially a decadal trend between 1960 and 2016 of roughly 8% decrease in precipitation, and concurrently also a decrease in stream flow. And unfortunately, the southern part of the country doesn't have too many observations. The few available also show, in terms of stream flow, they also show a decrease in the trend. There are a few stations that have, say, roughly 50 or 60 years of data. But in general, we know, knowing the hydrology of our basins, we know that this lack of precipitation translates into a stream flow decline. And this country is extremely sensitive to water deficits, which makes us extremely vulnerable to climate change. One of the patterns, and I will show you, is a drying patterns towards the south. There's this multi-decadal drying trend, and the impacts of this drought. Since 2010, we have experienced already a 10-year drought, which is quite different from these droughts that we used to experience that last for 1 or 2 years. And this is the area where most, roughly 90% of our population lives. So it's no game. It's a thing, a very serious issue, that we are losing the sources of water. Even Santiago is facing quite an extreme drought that has put the water services at risk. This is a city, for you perhaps it's small, but for us it's a very big city with roughly, this region, Santiago region, has roughly 8 million people, and we are experiencing more and more this severeness of drought and lack of provision of water. We haven't experienced that so far, but the water magazines are drier and drier. So we are about to live a huge crisis, and we have to do something to face that. Talking about platforms, in this Explorador, you can find and get data of precipitation and stream flow for Chile, and that's been condensed in that platform. And you can find more details in this paper, and there are quite a number of papers regarding the drought. Now, an interest exercise we made was to look into which were the reasons for this extended in space and long-lasting in time mega drought over central and southern Chile. And there is a significant signal from the warming due to greenhouse gases that essentially pushes, for those who have studied circulation, essentially expands the Hadley circulation towards the south in this case, making it warmer and drier over central and southern Chile. But also, and it's very important, over the southern part of the country, the lack the ozone hole has an impact on the strengthening and the weakening of the winds surrounding Antarctica, and thereby the precipitation affecting southern Chile. So part of this drying can be attributed to greenhouse gases, part can be attributed to the loss of stratospheric ozone, and there is also a significant part that deals with the natural variability, El Nino, the Pacific decadal oscillation, etc., etc. So we have been able to study the reasons that drive these changes, and we have seen how, long-range impacts affect the precipitation and the stream flow over central and southern Chile. And also from climate models, we can try to assert how the future will be. By the end of the century, eventually this effect from the ozone loss will be improved because the ozone layer is recovering to some extent. And there's also, but the problem with the greenhouse gases will persist over central and part of southern Chile. So this is one of the issues that we have dealt with, this drying and warming trend over the subtropics is something that is drastically observed over other areas of the southern hemisphere as well as the northern hemisphere. We have seen similar features over California in North America, over South Africa, over Australia, etc. So this is an issue of concern not only in Chile, but also elsewhere in the world. Another type of study we have performed is the following. We have a bunch of very skilled paleoclimatologists, in particular people who look into trees for trying to infer precipitation temperature records that go well beyond what we are able to recover from observational records. So this is a type of tree that is good for collecting precipitation data and eventually also temperature, but in particular precipitation data. In this middle picture, hope you can see, this is an estimate of the stream flow or the runoff. In black, you can see observations over the last, say, 50 years or so. This is a tiny, this case is one river in central Chile. And you see these black lines go up and down, and that reflects the variability I was talking about over central Chile in terms of precipitation and thereby in terms of stream flow. And what you see in this light line here is the reconstruction of precipitation and stream flow one can make using these paleo data. So this is quite amazing, and you can go back to the 1600. So even in the years that the Spaniards were conquering South America and Chile in particular. And using models, we are able to look into the future and what we see is essentially this pattern of drying and warming over central and southern Chile. So we can have a very long-term perspective of the stream flow variability. And also in this paper by Barria and company, you can see how the water rights are allocated in the case of Chile. And this is a peculiar thing that happens in Chile. Water use rights are perpetual. So once you have a right, you can have it for you and for your children and for their children, etc., etc. And that allocation is made based on just 50 years of records of instrumental record of stream flow. And you see, one of the issues is that with 50 years, you cannot capture all the variability in the stream flow. And you cannot project the variability of the stream flow. So one of the problems we are seeing, not only in this river discussed in detail in this paper, but in many rivers in Chile, is that the water rights are over-allocated. That means we are giving more water rights than is feasible according to physics. And the water law, the current water law, doesn't follow the laws of physics, but some other laws, and that's not sustainable. And that's something we have called upon using science to make that message clear for policymaking. And you can read also this paper in the literature, and is open to everybody. And here we also have a system, the CAMELS system, which is also a platform for accessing not only stream flow data, but also there is a balance for every basin along Chile, which is a huge work along the mountains, and also of water rights. So that's a very useful platform if we want to learn about water rights in the case of Chile, which is important when you have any economic activity in this country. Another issue we have dealt with is fires. Chile experienced in 2017 what is called a storm of fire. Essentially, roughly 600 kilometers of this country, of this linear kind of continental Chile here, from southern Chile up to Santiago, we experienced a month of fires, huge fires, which you can see here, a plume of smog and also of a fire plume that extended over the ocean, interacting with clouds, by the way. And what happened? We had experience already, and here, the other picture you see here is the number of fires since the late 70s up to now, roughly. Here is the fire of the 2017. This is the number of fire, this line here. So you see an increase in the number of fires, but also this is the red lines, or the red bars show the burned area. So one of the things we see, particularly over the last decades, is an increase in the extent of these fires. And there are a number of things that have contributed to that. One is the mega drought. The soils and everything is drier, so it makes it easier for the fires to propagate. But also, we have seen a land use change over the last 40 years in which native forests have been exchanged or changed by these pines and eucalyptus, which are very flammable tree species. They come from elsewhere, where fire is a natural and recurring thing. And so these trees, they are fine with fires. They burn, but they grow very rapidly. Not so the native trees we had in those areas before. And in fact, in 2017, a large proportion of these plantations were burned down. And as I said, it was a dramatic situation. We couldn't deal with it completely. Our institutions were not able to face the problems. And that's a typical feature of the Anthropocene. It's that we are prepared for a certain level of changes, but the changes we are seeing overpass the capacity of our institutions. We are not prepared for the type of changes we are seeing. So we have to change. We cannot prepare as we used to. We have to change the way of preparing it. And this was summarized in a report on fires and the changes in fire regimes in Chile. And this is also something that is happening particularly in the subtropics. You've seen the fires of Australia, the fires in California, the fires over the Iberian Peninsula, etc. So we are seeing a number of changes and very dramatic changes in terms of fires. Also, and now highlighting part of the work that is done for people from the social sciences, this is a risk estimate due to fires in the area of Valparaiso and Viña. Valparaiso and Viña are cities that are roughly 100 kilometers northeast from Santiago. This is the metropolitan region. This red thing is Valparaiso, and you can see a picture of this harbor, which is Valparaiso. That's is a well-known harbor in the Pacific. Once upon a time, it was a very important harbor because it was the harbor or one of the harbors people came to after crossing in Patagonia, the Drake Passage, which wasn't a very nice, or the Magallanes Passage, which wasn't a very comfortable passage. And now this port and the surrounding cities, Viña del Mar in particular, this conurbation here, we have a hazard. We have the menace of fires. And this menace is important because we have a lot of forestry around here and the conditions for having fires. Sometimes you get high temperatures, low humidity, and strong wind. And when that happens, typically 30% humidity, a 30 degrees Celsius of temperature, and more than 30 meters per second, and you get the perfect condition for fires, and that's a hazard that has affected this area tremendously. This is an area with a very strong topography, a very abrupt topography, and people live on the hills and to some extent here in the plain areas, but essentially is a very hilly area. So, but not everybody is affected the same way, or not everybody is susceptible, sensitive to the risk or the hazard that fires provoke. So what you have here is a map of susceptibility that includes the issues of the capability of people of facing the crisis, of the decision of living or not living on those hills. That depends on your economic power. And susceptibility is characterized on the basis of social information. The exposure, how much you're exposed or not to that, again, is a compound factor that depends on a number of social and economic conditions. And finally, the crossing of hazard, susceptibility, and exposure is what we call risk. And they have been able to build this risk maps for a few places because it is relatively easy to say when you have the risk or the hazard of having fires, because that depends essentially on physical parameters, and you can model that. However, to say which is the risk, and for that, the exposure and the susceptibility is much more difficult. You need more information. And a number of maps are now being launched in what we call an atlas for climatic risk for Chile. Is a work for continental Chile, facing all of Chile, including a number of risks, including water shortage, including surges by the coast, etc., etc. And this has been a work led by the center, but also in collaboration with other universities and centers in Chile, and certainly the Ministry for the Environment. So this is the type of work we do, and this definitely we need to have the combination of sciences. Finally, or not finally, but one of the other things that we have looked at as a group is the way of governance. Chile is, and I guess it won't be very strange to you, Chile is a very vertical, decision making is very vertical, is very top down, and also very centralized. Still, we have talked about decentralization in this funny country with a very long country along the continent, plus plus Easter Island or Rapa Nui by the ocean. But essentially, we take decisions in Santiago, in the capital. So that's been the paradigm so far. And in spite of a lot of talk about it, we need to transition to a more multi-level, what is called a polycentric approach, in which decisions are made not only from in a top-down manner, with very little response from the bottom up, but also at the different levels in a manner that includes not only, say, politicians, but also science and scientists, and also, more importantly, even so, citizens, because the changes we need require of changes of behavior. This is a societal change that is needed. So we have to put a lot of effort into changing that. And I tried to speed up a bit because I guess I'm running short of time. The other issue I wanted to address is, and the latest report we produced is air quality. This is central and southern Chile again, the place where people live essentially. And here is air quality data for 3 years, 2017 through 2019. This red line shows the air quality standard we have for daily averages of particulate matter, PM 2.5. And you can see all of our cities surpass that standard. In every year, roughly 80 days per year, these standards are surpassed. 80 years in the case of Santiago, but even almost the whole year under the condition of very bad air quality. And a lot of that air quality problem, particularly in central and especially in southern Chile, has to do with the type of energy or the lack of energy, the lack of access to good energy. And what people do is use wood burning. And that causes a lot of issues in terms of health and in terms, by the way, of emissions of black carbon. So in order to address these issues, an inventory was made not only for residential burning, but also for transportation and from many other emission sources at by 1 kilometer square, including greenhouse gases, and a model, perhaps you know the Weve model, which is a meteorological model, and Chimère, which is a French model for air quality. And essentially, my colleagues simulated the air quality for present conditions and also considering the measures at hand for the next 50 years and try to look to what extent these measures were efficient enough. Also, and here again, the paleoclimatologists, they reconstructed using a number of measurements in central Chile, for instance. They reconstructed the black carbon emissions from the 19th century up to roughly present conditions. And you see an increase, and this is a manifestation of the Anthropocene, and you can even see the acceleration, the great acceleration after the 1950s. So that's something that's happening in Chile. That's also a paper you can read. So in order to contextualize the changes, to say how big the impact is, paleoreconstruction are extremely useful. Now, looking into the barriers to energy transition in central and southern Chile in particular, this is not Santiago, this is a city in southern Chile, where you can see the living conditions are not very fancy. These are poor people using these very old devices for warming and cooking, and also for sharing in terms of family. The activity in these housings is essentially occurs around this kitchen. So essentially in southern Chile, there is precarious housing with, on the one hand, good ventilation because there are holes and there are badly insulated these buildings. People don't have the money to access good quality energy, so they use wood. They cannot even storage dry wood, which is a bit better than wet wood. There is a lack of knowledge in how to use efficiently those devices. There is a cultural thing of having wood burning as the good burning. That's a good source of energy. So people don't change so easily. It's not just a matter of changing these apparatus. You need to also respect and consider the culture. There is a market, an informal market of wood. People live by cutting trees, and not always, and definitely not always the trees I show you in terms of eucalyptus and pines, but more of the remaining native species. People don't are not engaged enough in terms of decision making. So there are a number of social issues one has to deal with in order to face the problem. It's not a matter of a pure technological change. It has to do with cultural and social changes. Finally, Santiago and the air quality. Santiago has improved its air quality significantly since the late 80s. These are daily averages of PM10 and PM2.5 in these dark lines, and you can see there is a decline. Certainly, policies have been efficient. Despite the city has grown 1.5 times, the number of vehicles has been multiplied by 3, population by 1.5, and we have become richer, at least on average, in terms of GDP. So people buy more cars and we use more and more cars. And even these cars are cleaner and cleaner. The number of cars is increasing, particularly over certain parts of the city. And this has to do with conditions that are this is a city that has strong social and economical gradients. So again, technology is not enough. And city governance and addressing inequity and behavior is very important. A short mentioning of one of the things we have discovered. This is PM 2.5. So this is the particulate matter that makes it all the way into your lungs and alveoli, and you see. You can see some sort of a decline overall, but if you look separately to this part and this part, you see very different trends. During the first decade here, you see a strong decade in PM 2.5. However, over the last 10 years, we have seen an increase in the trend. So the trend is changing. So we wanted to explain this increasing trend. And essentially, we looked into photochemistry for those of you studying something along those lines. For instance, with Professor Tong Su, you can see, we can see in the observations an increase in the oxidative capacity of the atmosphere that is driven by an increase in NO2, which in turn reflects a change in the photochemical regime we are living through. So we are seeing this increase in PM 2.5 is essentially driven by the change in this oxidative capacity. And you can see here by the eastern part of the city, the wealthy part of the city, you see an increase in the fraction of PM 2.5 that is not emitted into the atmosphere directly, but that on the contrary is secondarily formed in the atmosphere. And that explains the trend change in the case of Eastern Santiago and something that is starting to happen all over the city, which means, and this is the message for policymaking, is not enough to consider the the cut of emissions, but also is necessary to address photochemical pollution. And that requires of other measures that we have talked to. I cannot stop before saying that we also had to deal with the COVID pandemic. And one of the things we have learned, which is very much interested, and there are some results around the world showing this as well, the people who have been exposed to particulate pollution in the world are suffering more of the COVID pandemic. And this is shown here in terms of the incidence of the sickness of COVID, but also in terms of mortality. So more people have died in areas where they have been chronically exposed to PM 2.5 and PM 10. And this is shown in an analysis made by our colleagues from the School of Public Health in combination with other experts. That's finally, in sum, this center has been growing or has seen the growth of a diverse community able to cross inter and transdisciplinary bridges as required by the times we are living through, which is the Anthropocene. In such capacity, we have contributed to deepening our understanding, but also to the public discussion and decision-making. And a useful manner to spread our research has been the creation of these platforms of data and information, but also the reports. So we still, in addition to curiosity-driven research, we focus scientifically on scientifically exciting and socially relevant issues. So, 谢谢.
Thank you, Professor. We have some questions on the chat. So I will read.
I see them in Spanish. Wow.
We have two in English and two in Spanish, and in very good Spanish. So the first two is, do you believe that Chile can fight climate change without the support of bigger countries? And do you think COVID-19 has a positive impact on climate change?
The first question, no. Not only because we are what we call, probably you know that we are an OECD country, so we try to play among the so-called developed countries. However, we put very little money in science at large, and we have issues, economical issues, no doubt. I show you that we are not a rich country, at least not equally rich. And the poor are still the large majority of our country. So we may need the support of other countries. However, that is not the main issue nowadays, I would say. The main issue for Chile is that, or the main issue regarding climate change is that climate change cannot be solved by one country or two countries. Is a way of living that we all share, and that we need a common effort to solve it. It's not that I'm not rejecting the help of others, and by the way, the idea of having Professor Tong Su as a part of our advisory panel during the first period of the center obeys to the idea of sharing with great countries like China, but also from great countries from Europe and elsewhere, because this is a common issue, is a common problem, and because we are open to learn from others, as well as others may be interested in learning from us. We also have interesting experiences. So, regarding the second question of whether, to what extent COVID has had a positive thing in terms of climate change, I think in a rather brutal manner, it has shown us that yes, we can change our behavior. We can use less cars, we can do that. Unfortunately, in terms of emissions, that hasn't meant too much. The papers are already out showing that this temporary 17% decline in CO2 won't have a long-term impact. It's not enough. I guess it shows a way to decline emissions, changing our behavior, our way of organizing work, for instance. But on the other hand, the amount has been small. We have seen some improvement in some places regarding air quality, but not everywhere. We saw in the case of Santiago, for instance, an increase of secondary pollution, by the way, and ozone increases. So the only positive thing I would say is that perhaps it made us more conscious of our vulnerability. And second, it shows the way to the changes we can actually make if we want to make those changes.
Thank you, Professor. And the last two questions are from Sanshun Sang from China, I suppose, and they're written in really good Spanish, but I will explain them in English for the English speakers in the session. So first, she asks your opinion about how the president from Brazil, Jair Bolsonaro, has handled the fires in Brazil internationally. And the second is your view on how some obsolete industries such as coal still generate jobs and profit, and how Chile has set some objectives on energy substitution.
Yeah. Regarding the first thing, I guess Mr. Bolsonaro is quite similar to Mr. Trump, and they don't even believe in science. So his policies haven't followed science or scientific advice, and the handling of the fires of the Amazon, to say the least, it's been poor, not to say completely irresponsible, and very cruel in a way, going back many decades, because there had been some progress in the case of the Amazon and Brazil, and the treatment and the respect to people, but no, with the policies and politics of Mr. Bolsonaro, and that, in addition to my own opinion, which is what I'm giving you, is also supported from the data. I mean, there's been an increase, a substantial increase. I think yesterday, scientists in Brazil launched a report regarding fires and burned area over the Amazon, and is not good news. And there was another question I forgot.
Yes, how you see these obsolete industries such as coal, and how they still generate jobs and profit.
Well, yes, that's true, and that's kind of a false dilemma. The thing is that they generate profit so far. You do not count into it the loss in lives, the loss in biodiversity, the loss in climate stability. If you count that into those profits, or you subtract from that profit those numbers, then you go into the minus side. So these industries are not only generally obsolete, but they are also unsustainable. They cannot persist. Now, regarding Chile, I think Chile is in a very much privileged position. We are rich in non-conventional energies, of course, solar energy. We have these beautiful mountains, which are accompanied by beautiful volcanoes and very warm air, not so far away. I mean, you make a little hole and you get essentially very warm air here. So we can use geothermal energy as well, something we haven't done. And not only how to say, you can use low enthalpy energy, geothermal energy, and that's something that's been, there are some pilot experiments in southern Chile, but there are some need of legal changes. So solar energy, geothermal energy, wind, aeolic energy is also something we are rich in many places. So we are a country that is rich in energy, so we can make it. And I think we have achieved an agreement in using those energy types. Even the private industry in the case of Chile has seen an opportunity for good business in terms of those energy types. So we have a relatively bright future, but still that needs investment, that needs agreement. And I think a long-term planning was agreed 2017 or 16, if I recall correctly. And that's something we need to keep pushing on to make those transformations. And also, in addition to that, we are rich in, as China is, in lithium, which allows for electrical mobility, and also we can produce hydrogen. So we have alternatives, but we have to be careful in being able to be careful with those resources, and also use all of them. There is no silver bullet in order to change the things. It's not that we are going to change one thing and everything will be right. We have to change many things simultaneously, and also use the different types of energy we have at hand simultaneously. In different parts of the country, different types of energy for certain.
Well, thank you for your answer, Professor Gallardo, and we're a little over our time. So I will just say thank you everyone for being here today. I'm sure you all enjoyed our presentation, and with this we conclude our a series of webinars on online education, China and Chile. So bye-bye, and I hope you have a nice day.
Thank you very much, and bye-bye.